Good afternoon, and welcome to today's Industry Week webcast, Factory of the Future, Optimizing the Plant for Industrial Transformation, presented by LNS and sponsored by Dassault Systems. My name is Adrienne Selko, and I'm Senior Editor with Industry Week. I'd now like to welcome today's speakers. We have with us Thomas Muth, Dassault Systems EMEA. He's a Global Strategic Business Development Director, responsible for MES, MOM, Digital Manufacturing, and APS Solutions, Software Solutions. He has more than 25 years of software and technology experience, serving manufacturers in aerospace, transportation, industrial equipment, consumer goods, and life sciences. We also have with us Andrew Hughes, who is Principal Analyst with LNS Research, where he leads the Factory of the Future coverage areas. He primarily focuses on industrial operations and manufacturing operations management with collaborative coverage across the Internet of Things, industrial analytics, digital twin, product lifestyle management, discrete manufacturing, and other industry verticals served by LNS. With that, I'd like to turn the floor over to Andrew.
Thanks, Adrienne, for your kind introduction. And also a big thank you to Dassault Systems and especially the Delmia brand for sponsoring this webinar and the ebook and surveys out of which it came. We couldn't do all the interesting research that fills our days with fun without the help of companies like Dassault. So thanks to all of the team there for being such good customers to us. And of course, thanks to all of you for taking your time out of your morning or your evening to listen to us. Factory of the Future is a huge subject that can take you down many technical and architectural paths. We can't explore all of them today, but we'll take a first look at some interesting opportunities. And very happy to say that Tom's got a great real-world practical example that expands for Factory of the Future a lot. So we'll really look forward to seeing that. First, a quick bit of advertising for those of you who don't know LNS Research. Our mission is very simple. We evangelize and drive industrial transformation, what we call IX. We've got fed up of typing industrial transformation, so from now, henceforward, we just call it IX. Our message and focus is simple. It's helping you to succeed in a changing industrial world. We do a lot of primary research that collects data across the industrial transformation landscape and concentrate on technology that many would call operational technology rather than information technology, OT rather than IT. But of course, these two worlds are converging, as we will see. In this fairly short presentation, we will share some of the research from our recent Factory of the Future survey, as well as a few first insights from our current Analytics That Matter survey that we do every 2 years with the MESA organization. That's just gone live, and we're starting to get quite a lot of response into it, and there's some interesting things I'll talk about. This framework shows the context in which LNS does all its research. The top swim lane is really the input to our relationship with industrial companies. We expect the board and C-level management to set the direction of, and most importantly, commitment to industrial transformation. Below the top level, LNS gets involved in boiling the business goals down to strategic initiatives and then to an operational architecture that can support these goals moving forward. And that's something we'll talk about at some length later on. And finally, we work with our clients on solution selection in the technology areas we cover, which include asset performance management, quality, MOM, Factory of the Future, EH&S, what else have I got? Connected worker, analytics, and of course, IIoT and things transformational. And then to the last stage is helping companies to actually implement and manage the change that they need. Few industrial companies that work with us. We also have a list of them that are even longer list of vendors that work with us, but we won't put them up here today. And just for your help, this is a quick view of what we offer our manufacturing customers. I won't spend any more time, but I wanted to put it in the slide deck so you have it for your reference. So we talk about lots of acronyms, sorry, and three-letter acronyms in particular, but we are interested in one two-letter acronym. What is IX? What is industrial transformation to us? People call things lots of different things, and we see IX as a subset of digital transformation. Digital transformation includes the whole enterprise, a lot of IT, a lot of the business, up to the board level, we're trying to promote the idea of industrial transformation as the operational side of digital transformation. It's difficult to get people to change their terminology. I actually put a question in one of our recent surveys about what do you call your Industry 4.0 or digital transformation or whatever program, and not many said industrial transformation just yet, but we'll work on it. This slide shows basically our reference architecture, our framework, and and how all the bits of an IIoT or industrial transformation architecture go together. There are lots of bits, and a lot of them are focused on the factory of the future, on the plant, and you could call it daunting, but remember, everyone has to start somewhere, and I don't think there's any company anywhere in the world probably that has already implemented everything that's hinted to on this slide. But certain foundational elements are required, such as communication standards, cybersecurity, especially in the industrial space, which is something that a lot of people are concerned with. Having data models, having the capability to store information, and of course the most important, support for applications and analytics across the board. So where do you start? When I started thinking about Factory of the Future a few months ago, before writing first papers on it, I was thinking, what new technology have we got out there? And in my hunt for new technology, I didn't find any, unfortunately. I found a lot of stuff that has been around for a long time. Vision systems in manufacturing have been around for 35 years. The oldest automated guided vehicle I could find, although it's probably exaggerating a little to say it's automated entirely. I didn't have a person on it, but that's 65 years old. And it's really true that nothing is new. It's just become easier to use due to much more processing power and more refined manufacturing processes, allowing us to build more complicated things with more complex and configurable factories. When you think back to our early forays into computing, I mean, I started my professional computing career in the very beginning of the 1980s, and we worked in kilobytes, and a megabyte was a dream. Now people talk about how many millions of lines of code it takes to write an app on your phone. So we're really living in a different world. We asked companies to say if they were actually using some new technologies in their plants, and we gave a list of what some of the industrial transformation technologies that we thought would be popular. And it's a very big mixed bag of responses, with machine learning leading the way. But we suspect that is mostly in analytics. It does not become that's not a huge surprise to us, because analytics has been a big leader in this marketplace. It's much more surprising to see blockchain up there, but most of what's nearer the top is hardware tech, such as 3D printing and hardened tablets, and that's what we expect to see from the manufacturing professionals to whom we address our surveys and who listen to webinars like this one. But we'll come back to these emerging technologies later on to see a different viewpoint. The Factory of the Future is not just technology. I think the first bullet really sums it up. It is IX in the plant. IX is cross and beyond the enterprise, and you'll see a great extended view of what we would call industrial transformation in Tom's presentation later on. While the Factory of the Future supports IX with the required plant technologies, solutions, people, and probably bringing the biggest change, connections. As we saw previously, the Factory of the Future is unlimited and covers basic tech like AI and ML, not that that's basic, but building block technology. Real machinery like autonomous intelligent vehicles, cobots, vision systems, and most importantly, almost connected worker technology. But the most important thing to realize when you're considering where to go is that there are many futures in Factory of the Future. This is not a single, it's not one factory of one future, it's the factory of many different futures. And it's a long journey, and the technologies you will use first will be different for everyone, with one exception, and that's really data, because it's almost the start of everything. We can't isolate Factory of the Future from other operational and information technologies. And you know, what's interesting we see here when we look at some of the major things like quality management, CRM, ERP, that our friendly plant-centric solution here in the MOM MES and even into industrial Internet of Things right down the bottom. You know, we've been doing surveys since the time of the birth of LNS 9 years ago, and this number for MOM has never reached 20% deployment. And we're really hoping that the advent of IIoT will continue to raise interest in MOM as a critical data source as we move forward. Another quick example, IX leaders that we define as those that have seen business success from their industrial transformation. Programs are much more likely to choose solutions that will appeal to the digital natives who are not the factory of the future, but the future of the factory. Everything in the successful Factory of the Future revolves around having the right people and providing them appropriate access to lots of data, what we start to call big data as we start to gather data from lots of different sources. You know, the leaders in industrial transformation companies know that the existing and old systems will not cut it for the digital natives. If you take nothing else away, take this thought with you. But herein, in a way, lies an ancient conundrum: IT and OT and business convergence. Our surveys still show that plant managers are often not the keenest to invite IT and others into their environment, into their playpen. The other way around is not much better, except that IT believes it can help the plant folks become much better information citizens, and that's probably very true. Something that we factory-focused people don't always want to consider. But an important takeaway here is that OT focus can be very beneficial to drive support for industrial transformation. There are lots of plant technologies that will deliver manufacturing benefits such as productivity and quality, while simultaneously making new data available for corporate level analytics. And as we'll see, the split between plant and business data has to become a thing of the past. Now, as we said, data is kind of important. And this slide illustrates a very key concept in the whole world of industrial transformation, is that old architectures need help. In the top left, you see a depiction of the very traditional ISO 95 manufacturing operations control hierarchy. And this is a depiction of a model that's been widespread use over the years. MES systems being installed all over the world and across many plants in a single company. And data flow was determined by the need for plant control and communication with business systems and basic monitoring. And this was fine for most people. But now along come the outsiders, and they want more data from your pumps, your motors, your machines, the stuff that you're actually building, anything that can be improved. And this leads to data being collected directly from the machines and passed to higher level repositories, bypassing the control system. You could go on a lot about this and could talk forever about the IoT-enabled devices you see on the other side. But my advice to OT people is, embrace the change and look towards better architectures as you move forward. Here we're trying to depict the evolution of IIoT platforms that support integrated data and application management at the business level, while maintaining partially or wholly separate operational data. This is typical of plants with integrated MOM solutions, but that still maintains some autonomy in data management, thus keeping some data ownership with operations and plant management. And that's important, that they're seen to have the ownership, or at least the shared ownership of information they really require. Architectures like this have typically evolved rather than being designed from the bottom up. Today, there are many vendors like Datasystem with centralized platforms, often running on one of the mega cloud platforms. These offer much more flexibility and a move to truer data integration. And this sort of view of an enterprise platform shows some of the key components of a truly integrated data architecture. We're seeing many IX leaders making the jump to a data lake-centric solution and using that to provide top-to-bottom access to data for all applications. In this picture, I've left out most of the data flow arrows for simplicity because they go everywhere. Everything can talk to the data lake, and a lot of things can talk to each other. So imagine the communications background sitting behind all these components. As we saw in our IIoT platform framework, some key components such as connectivity and security serve the entire enterprise and allow safe access to process and plant data to everyone, and access to the analytics programs and applications that they need to do their jobs. An important component for plant and operations staff is this, what we call local data and edge computing layer, where plant data meets IT. Data historians, equipment data, and even production orders that require 100% availability can be accessed from the edge while residing, often in consolidated form, in the data lake. Because we're not going to pass up every single bit that we get into a data historian up to the data lake. The ability of the lower levels to clean that data and make it into useful forms is important if architectures like this are going to succeed. Those that use consolidated data in some form or other have made great strides, really, in incorporating a wide variety of data sources, ranging from financial to sensor data, with quality production information right at the top. This is encouraging, and much more encouraging than we expected to see so many different data sources being used already in a single data lake solution. And it really does open up the opportunities to build applications and use big data across that comes from across the enterprise, and even 12% of companies are using data external to the company in their enterprise data lake. That really is exciting. Now, just a quick sideline on analytics. As the IoT became popular and companies started to look for opportunities to run pilots, really the universal low-hanging fruit was always analytics, especially related to asset performance and general maintenance, predictive maintenance, and so on. Times have moved on a bit, and we're moving from simple analytics to sophisticated prescriptive analytics with direct feedback to operations staff, and just seeing the start of direct control to plants and processes. Operations staff have, probably rightly, been very wary of direct control for analytics, but this has been the norm in many process industries such as chemicals with advanced process control, APC, and online real-time optimization. And as analytics mature and as new technologies are moved into the factory of the future, we'll continue to see an increase in trust. And that's very important, because if you can trust the results of analytics coming out of your long-term sophisticated analytics programs, then we will see true prescriptive analytics with timely feedback to not just people but machines as well. There's just a couple of key points for reflection here on where analytics are going. One of the important changes we see driven by the IoT is the collection of plant data that's not used for control. It often bypasses traditional channels of PLC and MES systems and goes directly to enterprise storage within, for instance, our theoretical data lake or other platform. And this gives opportunity for new analytics without upsetting control systems. Again, just for interest, this is the business and manufacturing processes that people are most using for analytics for improving manufacturing quality and better forecasts of production. I think are great top ones, but they're there for you to look through and comment on as you wish. Moving on from technology to cash, you need to find the FOF opportunities that will deliver value. Here, there are just a few possibilities. I don't want to spend any time on them. But thinking back to the very start of the presentation where we talked about business objectives, we've got to make sure that the things that are proposed in the factory of the future and the early industrial transformation, that they must drive the C-level objectives of the company. If they don't, you'll lose the support very quickly. And it's only through top-level management support that these things can permeate throughout a company. However, there's always the hype. And we looked at different technologies and the introduction of those different technologies in companies. So we thought we'd also ask the question in our recent ATM survey was, what do you think is the most overhyped technology? And to be honest, the top three are a bit worrying. And it shows to those of us like myself who come from a software background and who come from operation technology and software. We have a job to do to ensure that trust is built in, trust in advanced software is built. I've been doing this software thing for 40 years, and sometimes I even get worried about, what's going to happen when we put artificial intelligence algorithms into our factories. Are they going to do the job as well as they can? Are we going to overheat our entire enterprise by running blockchain? There are lots of real examples, but we've got to make sure that we experts in the field allay the fear when the fear is just pure hype. Now, very quickly to finish, I've only got a couple of minutes to go. A few other factory of the future opportunities, some of which Tom will talk about, so I'll skip them. Digital twin being a very good example. As we go more sophisticated into plant and integrate digital twin with a platform that brings product, the business, and the operations platforms all together into the enterprise platform, the opportunities for digital twins are going to be absolutely enormous. Everyone likes talking about OEE. Actually, this is entirely untrue. I hate talking about OEE because I think it's so over-abused as a manufacturing measure. But it has some real potential. But I still think that one of the things that I have been thinking about a lot recently and keep reflecting on is, why are we measuring equipment performance? Why aren't we measuring people performance? We'd be much better off with OPP, overall people productivity, or workforce productivity. But that's really a discussion for another day. But if you are using OEE as one of your early metrics in your industrial transformation, make sure everyone's using it the same way, everyone's measuring the same thing, everyone's counting in the same way. That way you can actually start comparing like with like and perhaps see the benefits of why one plant or one machine is performing better than another. This leads us from the factory of the future to the future of the factory, and that's empowered workers. Two things to consider about empowerment. Employees will only be empowered if they have information to help them do their job. That means being connected, having access to the appropriate data, and secondly, having tools to do their own analysis so they can address issues from their viewpoint. We're starting to see the advent of low-code and no-code application environments coming into the manufacturing space through some big vendors and big manufacturers looking at how they can use those in their plants. It's early days yet, but I think it's very interesting because in order to be able to do that, you're going to have to bring the proper tools to the workers so that they can be empowered to optimize quality, to correct production before it gets out of hand, and so forth. This is absolutely vital to the future. Now, we know that there's I didn't want to go into it in detail here, but we know that there's a big shortage of good quality workforce in our factories today. Let's make it exciting for them to be in them, just as we were excited to be in the software world 30 years ago. This slide really speaks for itself. Finding a starting point, getting executive buy-in, making an integration strategy, and sticking with it. And most of all, use the people with the knowledge to make it work. With that, can I ask just one thing? Do something, please. Factory of the future bounds you inside the plant, sort of it's the IX inside the plant. But the factory of the near-term future is just around the corner. There's lots of technologies you can use today. And if you take anything away, focus on integrated people and integrated data, and you'll not go far wrong. With that, something much more exciting now, a real-world example from Tom.
Okay, thank you, Andrew. Appreciate that. Again, my name's Tom Muth. I'm with Dassault Systems. For the remainder of the webinar, we're going to talk about Factory of the Future from a broader context, and how do you bring that together? What are the different aspects of the Factory of the Future? And some example of more of an end-to-end Factory of the Future implementation I'll talk about at the end. As we talk about the Factory of the Future, of course, it can be a daunting task, but it can also be attacked in a very modular way. Some companies will have a broad vision end-to-end for their Factory of the Future. Others may start in one area and move forward into other areas that would be a priority with the business. The bottom line is each manufacturer needs to have their vision of what they're trying to achieve in the long run for the Factory of the Future. And that doesn't mean long run as in 1 year. It may be, you may be looking at a 5, 6, 7-year journey and dealing with the combination of new plants, new operations, as well as what most of us are dealing with is brownfield sites. So what I'm going to talk about here is really Factory of the Future as we see it, how it comes together. And so how we see the Factory of the Future coming together really starts and may be important to look at from a modeling and collaboration standpoint. Starting with process engineering, where you're actually doing the actual plant layout and systems layouts and your process workflows, the manufacturing engineering in terms of optimization, and also encompassing your value network. In other words, your supply chain optimization that's important to look at in terms of the Factory of the Future. And then performance and collaboration within the operations. And this is typically what you would think of as your MOM operations management space. As I mentioned before, it depends on where the pain is, on where you start on that journey. And I'm going to talk a little bit just really kind of how that comes together, and then give you an example from a customer of ours that have kind of taken that whole view. So if I move forward from a standpoint for process engineering, what are we talking about? Well, with process engineering, really we're looking at the opportunity here to define a plant layout. And if you have an existing plant, you may be defining a plant layout in terms of new lines within the plant. So not necessarily does this have to be a ground-up exercise. And in doing so, helping to simulate the factory flow, simulate machines and ergonomics that are part of that process, and train virtually. The idea here is getting it right the first time before going into production, and really cutting down on that time required for new product introduction, which is critical for go-to-market. In defining the plant layout, you may have an existing plant layout already. You may have CAD drawings that you can bring in to start to model. In some cases, you may even have the opportunity, and we work with a vendor that actually will build a cloud of points, very much like walking through a Google Earth, simulation, and then create that file itself that you can then start to model and simulate. So a lot of different ways to approach getting to that stage, but overall, the technologies are there to support that. In terms of simulating the factory flow would be the next step in that process. So simulating and optimizing factory flow, work cells, and looking at optimum flows based on demand and product. Before finishing that process, it's always important, especially in a discrete scenario, to look at how can you optimize and simulate your machines, and even ergonomics within the process. So in ergonomics, you're looking at time and motion studies for optimal performance, and you're also wanting to look at how that works across different types of workers, and ensure that the repetitive tasks are done efficiently, but also in the most healthy fashion for OSHA requirements. And of course, by having all of that, one of the side benefits is going to be really being able to train virtually as well. So using that same information, now my workforce of the future can be trained virtually in that environment. And that's real important for new workers coming on board, as well as maintaining, in our factory of the future, maintaining the best practices from one workforce to the next. And then, as I mentioned before, training virtually. So here's an example. You may be able to train virtually a workstation in terms of doing assembly, process assembly, work cell assembly. So the next area is really around manufacturing engineering. And for manufacturing engineering, again, the model here is quite important in setting up and thinking about where do you want to manage that model. Because having that model being developed is important in such that it can be maintained and continuously optimized. Very similar to when we think about digital twin and reference to that, the digital twin is an aspect of the factory of the future. It becomes a natural deliverable as we go forward, very much like leveraging different technologies like IIoT as well in the areas of operations management and continuous optimization. So within manufacturing engineering, what are we talking about here? Well, here we're looking at finally creating, our product and resource definitions and our process plans, as well as creating electronic work instructions that will be used within the manufacturing environment. So here I would be defining my product definition and resource definitions in a model, and then go on to define the process plan in that same model, and then looking at ways to optimize the process. From there, I can then start to leverage my work instructions and deliver that across the application. Now, as we go forward, now I have my model, my processes, my work instructions, and I want to optimize that same process according to my value network, my supply chain, and my schedules. Now, a lot of cases that's done after you go into production, but we work with companies today that are looking at that, doing that, simulating and optimizing up front. Again, trying to get to rate as fast as possible in order to meet demand and also level demand and ensure that, you know, startup processes are done smoothly. So from a value network optimization, what are we talking about? We're talking about planning and sales operations, S&OP, optimizing your logistics, and optimizing your AGV and plant traffic as well. AGVs are being used more and more traditionally now in most manufacturers, whether they're consumer products manufacturers, whether they're discrete, anywhere where you're requiring material movement and material synchronization. And for sales and operations planning, really looking at optimizing the optimal performance for schedules and materials and inventory, you know, across the enterprise. So this is where the factory of the future, you know, looking at a single plant level is not always the best approach, because how does that interact with the other plants? And then how would your plans for the factory of the future interact with your supply chain? So these are some considerations that you'd want to look at. Again, not something that you have to do right away, as we see a lot of customers, you know, take meaningful, realistic project sizes and execute those first. But having that vision is important, or at least recognizing it should be on your transformation roadmap. Optimizing logistics, you know, for some companies, this is a huge aspect in terms of delivering, you know, that last mile, especially in the consumer world. But we're also seeing that also in other applications. And then lastly here in the value network is looking at just optimizing AGV and overall plant traffic. In here we want to use algorithms to simulate and give us the best possible view of an AGV optimal approach according to my work plan and my processes themselves. And then lastly, we get into operations management, where operations management really is around these four areas. The four areas being, you know, your production plan and scheduling. This is not to be confused with S&OP, but this is really that plant planning and scheduling that's done on the plant floor. Not surprising, we see a lot of companies that are still doing that in Excel today after getting the orders laid out from their ERP system. Manufacturing operations, which is really around MOM. And then IoT and analytics really is leveraging that real-time data from within MOM to do improved, better decision making, you know, including things like what Andrew had talked about around machine learning and AI. And lastly, digitizing your lean operations, lean management across the factory. So from a production planning and scheduling, I mentioned before that many companies are still doing this in Excel. Some companies have moved on to an APS, but a lot have had this in the area of Excel in the past. And so we still see companies that are moving that direction. The idea here is to do the optimal, you know, schedule, to ensure that the schedules are optimized against my workforce, my production orders, as well as lower the inventory cost, carrying costs for materials, all of which, you know, needs to be connected into the plant and done on a real-time basis. So you have continuous optimization of that, rather than, you know, a weekly update of the plan or schedule, or maybe that plan or schedule is updated at the end of the day. very critical in terms of, you know, a complete MOM solution. From a MOM standpoint, really talking about taking those work instructions with my Factory of the Future, their digital work instructions, and driving that into use within the MOM application itself. You know, whether it's for production, for quality, for warehouse management as well. And then leveraging the analytics now. And so driving analytics with IIoT and manufacturing. Analytics that go beyond just OEE, but really drive home, you know, how are we doing to plan production quality, workforce performance, and any other, you know, critical deviations that we want to monitor and optimize. And the last, really here in the MOM side of things, is really delivering a digitized lean operations. This is an example of a digital lean board, if you will, but going beyond lean itself to do better issue management and task tracking. A lot of lean operations and lean boards today, as you know, are done, you know, really in a more manual approach. And here what we're doing, we're talking about digitizing the lean processes and capturing that information in a more collaborative environment. You know, I mentioned collaboration across all of these areas, and that's very important because the collaboration really helps break down those silos. So the Factory of the Future, in many respects, has, if you can look at it in a context of your organization, you know, your industrial engineering department, your manufacturing engineering department, with your operations and your supply chain planners, really all need to be interconnected in this new Factory of the Future. So collaboration, in order to do continuous optimization, will be a critical path and goal for that Factory of the Future. So, again, how it comes together, starting modeling and collaborating with process engineering and manufacturing engineering, looking at your supply chain network and optimization, and improving performance and collaboration in your operations management areas. That's how we feel the Factory of the Future comes together and driving that forward. And as one example is a large aerospace manufacturer. And in this case, they had the luxury of starting with the greenfield facility. They're manufacturing aircraft fuselages. And so in order to meet demand and ramp up for production as quickly as possible and get to a steady state, you know, they decided to implement the Factory of the Future. And you'll see a lot of different aspects in which they approached it. So in the case of their Factory of the Future, they looked at these processes, and I've got another slide here that will talk about additional processes as well. But they started with the 3D modeling of the building that they wanted to put together. And they built that, and they were using Dassault software in our platform to basically build a 3D twin of the entire building and inside the building and the pilings and everything else that would be a part of that. So what they wanted to do is first off have a realistic representation of the plant itself. They also wanted to, you know, assess the impact of the building design itself on construction. In some cases, you know, it's even just getting equipment into the building. You know, if the doors aren't large enough to bring in particular equipment or the movement itself. And then they also wanted it to help with, it was really a prerequisite for the next steps in their process. So by doing so, then they also did simulation on the factory layout and floor itself for laying out the building and optimizing, you know, the actual way in which they would collaborate around putting machines and equipment across, so within the plant itself. So they really wanted to do this to to drive a faster layout in delivery. Also use it as a means to collaborate amongst the various team members in such that they had a better process and result. Again, all of this is trying to shorten the time to market, if you will, in this kind of this first area. Next, you really looked at flow simulation, basically simulating the workshop and the workers and the material flow all combined, and looking and doing actual analysis and doing time and work analysis to understand, what was the optimal approach for flow within the plant, and also do some what-if analysis based on different demand changes as well. And that's where you see the next item, which is really taking an APS tool and doing that up front to do what-if scenarios and simulation of the process, so that I'm also optimizing my flow based on demand itself or expected demand. And in many cases, especially with new products coming to market, demand can be uneven for a period of time until the business gets into more of a steady state. And so that can be pretty expensive as you run through that stage of the business. And their goal was to optimize that and get to a steady state as fast as possible. So the ramp up time, really the benefit there was being able to validate scenarios of ramp up time, and also validate the demand feasibility. What can we actually offer to our customers in a realistic fashion as we move forward with this new facility? Then getting into the real side of things, so all of that was more in the virtual world. Going into the real side of things really is, implementing the core MES for operations. And so the goal there is really, and the benefits is just shorter work in process, lead time reduction, ensuring the product's done right the first time, and of course continuous improvement. And by doing so, taking that and then now using from the real-time MOM information, driving that into their advanced planning and scheduling, where they can now do that more in a real time to, again, understand what's actually happening on the plant floor and continuously optimize their plans and schedules such that they have, lower work in process, lower inventory costs. They're getting more out of their equipment and people in that same vein. And as any operations side, the performance management was really important as well. And so this is where they use some of the virtual modeling and simulation capabilities to drive 3D, being able to use that and reuse it for 3D monitoring of performance, and also use that in the 3D work instructions to have a more realistic view, by also being able to feed quality data in that model back to the industrial engineers or the manufacturing engineers for changes in product design or improvements in processes. And lastly, moving forward, is they're digitizing their lean operations. And so, they wanted to digitize what was more of a manual process, whiteboards, around the plant, doing their lean operations to a more collaborative approach that also captured all the lean practices and improvements, so that they had quick access to all the indicators in their lean meetings. They could speed up issue resolution as well as do a better means of tracking those issues. And then just also improve the operators. And this is very important for across all of these areas, for their workforce of the future, as they see new workers coming in, and then trying to digitize and appeal to those workers that are used to working in that digital environment. So for those of you that don't know Dassault Systems, just real quickly, is is we're a scientific company. We're based in France. We're a global operation with 17,000 people across the globe, with 230,000 customers, ranging from 11 industries in 140 different countries, using our software not just on design, but also in manufacturing, simulation, across all industries. And we go to market both direct and also through certified partners on a global basis. One thing you'll find with Dassault is we're very long-term driven. We have a large focus in R&D. We spend a high percentage of that in there. And, we look forward always working with our customers and partners, to work out those next generation impactful technologies that really make an impact, not just in the business, but also society as well. So with that, that concludes my section here, and we've got about 7 minutes for Q&A. And I thank you again for joining, and I'll turn it back to Industry Week.
Okay, great. Thank you. We do have some questions, but I would like to ask our audience that while our presenters are answering the questions, take a moment to complete the feedback form in the lower toolbar. Andrew, I'm going to start this question with you, but then I'm guessing, Tom, you'll have a few things to say as well. The question is, as our factories evolve, how will we prepare our factory employees? Have you thought about strategies of upskilling our workforce in terms of readiness, and how would learning and programs adapt to help?
Yeah, that's a great question, and one of the most important ones that needs answering by all manufacturing companies. One of the things that I think is very clear is that manufacturers, have to get away from living in the old world of the classroom and start using modern technology, AR, VR, wearables, and so on, in order to help the upskilling of the workforce. I believe that the thing that really helps to upskill the workforce is making tools available to them. That's why I was talking about low code, no code, so people could actually build their own dashboards just for their own personal use on their own phone or their own tablet. And so I think, there's a huge opportunity to take digital native technology and move it into the factory and use it for providing the information needed to learn rather than just training. Because, my now 20-year-old daughter, she's never been trained in the use of an iPhone or a tablet or anything. It's completely second nature. So I think that putting the technology in front of the people will allow them to train themselves, as well as more formalized training, like with AR and VR and so on. Over to you, Tom.
Yeah, I would just add on to what Andrew said. We see a lot of companies that we're working with that are trying to take their tribal knowledge, if you will, and also leverage that to take best practices into upskilling the workforce. And to get into a collaborative environment, obviously you need to get that into an electronic form, and you need to have a collaborative platform to enable that. And that's where we see the importance for leveraging that medium to really help that workforce. It's some companies that are advanced in doing it are definitely doing the virtual training, as I had referred to before. But we have all types of manufacturers that are looking to do that and really do it in a platform, do it in a context of what they're used to working in. Like Andrew had mentioned, the workforce of the future is used to working, in a smartphone. They're used to virtual environments, and those are areas that are clearly things that we can support.
Okay, thank you. Tom, you want to give a definition of mom?
Oh, sure. Mom. MES, I think people are familiar with, which is Manufacturing Execution Systems, which covers mostly production execution and quality. But MOM is more the broader aspect, where MOM covers not just the execution side, but also performance and scheduling optimization. So MOM is really a broader term in terms of manufacturing operations management, where you're looking at your entire operations, not just the production execution side. Andrew can add on to that as much as he wants as well.
Yeah, thanks, Tom. I would slightly defer. I think that the trying to differentiate between MES and MOM has become a marketing tool by many of the vendors in the space, and I think it's very confusing. And I wish, but this won't happen. I don't think that they become synonyms. In that, as Tom says, the MES was what came first, if you like, and then it was expanded out to what I still think of as MES. I mean, scheduling is part of an MES system, and every vendor I talk to, and there are loads and loads and loads of vendors out there in the MOM/MES space. Everyone has a different definition of what MES and MOM is, and so I like to take the definitions from ISA 95, which was the picture I put up at the beginning, and say that is MES and that is MOM. You use whichever you prefer, and people will continue to do so. I mean, I totally get Dassault's view of MOM is expanded from MES, but it's not universal, that view.
Okay, I'm going to get one more question in as we're kind of running into time, but this question, maybe Andrew, you want to start, and then Tom, going in our last minute. What are the top 3 characteristics of a plant manager to possess to be effective in a plant of the future?
Openness, willingness to change, I think is probably the single most important thing. The plant manager is is seen as a real leader inside the factory, even if they're not necessarily seen as a leader in the enterprise. But that leadership role is really vital if they're going to successfully implement Factory of the Future in their plant and across many plants. So they have to, clearly having a good understanding of modern internet technologies, IIoT, and analytics and so on is helpful, but they're not going to be skilled in those, but they have to understand. I'll give Tom the last minute.
Yeah, I would say the other areas, certainly, openness, but also plant manager needs to really have good connections across the entire organization, because as you saw before, it's going to be important to work not just across within operations, but also within their engineering and their supply chain departments as well, their planning and schedulers. So they're really going to require leadership, and also they're going to want to make sure that they have executive buy-in at the very top of the organization in order to make transformation happen. They need to be empowered to do so, and they need to have that executive agreement on that, because there will be barriers in making those changes. There's a cultural change. In many cases, it's less so of a technology barrier as it is a cultural barrier within an organization. And it's important to keep momentum going. So, when you look at transformation projects that might seem daunting, it's important to have those quick wins to maintain momentum and also maintain buy-in in both at the executive level in terms of that transformation, but also within the ranks, the folks that are actually doing the execution. So that's a real important aspect, and so they'll need that type of characteristic in order to drive forward. It may be a couple individuals, but certainly keeping that momentum going is critical in making a success, because it is a journey. And you can start in any number of areas, but you have to have that vision, and you have to have the executive commitment to make that, make you last on that journey. Otherwise, you're going to have a start and stop, and people are going to be frustrated in that transformation journey.
I would just add one thing to that. I would just add one thing to that is buy the CIO a beer.
Okay. I'd like to thank our speakers today, Tom Muth and Andrew Hughes, for an excellent presentation. I'd like to thank LNS and Dassault Systems. As a reminder, if you're registered as a group, please add the names and emails of all in attendance on the exit survey. And on behalf of Industry Week, have a productive remainder of the day.